Alright, we're going to have a look at creating the graphs for y equals sine of x and y equals cosine of x. Okay, we're going to start with the sine function. So if you recall from our unit circle from last time, if I'm looking at the angle between the positive x-axis and a point on the unit circle, so my unit circle is just kind of off to the side here. Okay, as this angle increases, this side here was my opposite side. So sine was the y value. So here I've got the y value of the point on the circle. So here the y value is 0, y value goes up to 1, y value goes down to 0, down to -1, and back to 0. So if I take my lovely little angle here, and I start increasing the angle, okay, the y value is going to start to increase starting from 0 until it gets to 90 degrees or pi on 2. Okay, and then it reaches its absolute highest y value it can on the unit circle, which is 1, so that it has to start decreasing. Once it gets to pi or 180, okay, it gets back to 0, the y value, but it continues decreasing down to -1, and then increasing back up to 0. And I can keep going around the circle over and over, and that's going to continue to repeat. What I've drawn here is the graph of sine of x. Okay, so it's called a periodic function because it does repeat periodically. It's also called a circular function because it's based on the unit circle. So let's just kind of formalize that a little bit. So from the unit circle, again, we've got a beautiful picture of our unit circle here. Because this is the opposite side and sine is opposite over hypotenuse, the sine is the y value over 1, so the sine is just the y value. So let's fill in this table. When sine of theta is 0, when theta is 0, sine of theta is also 0. And then when I increase up to pi on 2, it becomes 1, back down to 0, to -1, and 0. So that's the y value as I go around my circle. Okay, formalizing just some kind of helpful hints when you're drawing it. As theta goes from 0 to pi on 2, the value of sine of theta is increasing. So it's going from 0 up to 1. And then it reaches its maximum of 1, so finally decreases back to 0, continues decreasing to -1, that's its minimum, so then it increases to the next value. And then have your go at plotting your very first graph. So we know sine of 0 was 0, sine of pi on 2 was 1, sine of pi is 0, sine of 3 pi on 2 is -1, and then 2 pi, just to get a little bit of a better shape, because we don't want it to be kind of a zigzag. You saw the nice curve. I can go to my special triangles and remember that pi on 4, which is halfway in the middle of course, was root 2 on 2, and if you calculate that, that's about 0.71, so that's going to be just about there. And then using my cast rule, it's just positive or negative, so it becomes positive, negative, and negative, but of course all the same value. And then I do my absolute best to get a really nice smooth curve through all of those points. That can take a little bit of practice. All right, onto our cosine graph. So it's very, very, very similar, but it does have some subtle differences that does set it apart. It's basically a phase shift. Okay, so that's the technical name. You don't need to know that yet, though. So on the unit circle, cosine of theta, okay, so that's this angle, cosine is adjacent. So this side, this length here, is my x. So cosine is the x value. Now, I'll notice that when theta is equal to 0, the x value is as big as possible. So the x value starts at 1. And then as I go around the circle, my x value decreases to 0, continues decreasing to -1. That's its minimum, so then it has to start increasing again to 0 and increasing again to +1, and that's just going to keep repeating. So to fill in our sentences, as it goes from 0 to pi on 2, it's decreasing. From pi on 2 to pi, going from 0 to -1, it's still decreasing, gets to its minimum, so then it starts increasing and continues increasing until it gets back to its maximum. Okay, so when I want to draw this pretty picture, Now instead of starting at 0, 0, I start with a y-intercept of 1. Okay, so I start at the maximum because it's the x value, and the x value starts as big as possible. Then it goes down, down, up, and then again, cos of pi on 4 is also about 0.71, so I can plot that. But then the cast rule in quadrant 2, it becomes negative, stays negative in the tangent, and then comes back to positive. So here's our cosine graph. You'll notice it's very similar to sine. It's just shifted over by pi on 2. Okay, so that's called a phase shift. So they have the same shape, but it's kind of their starting point that is the difference maker. Okay, so have a go at filling in those sheets, and we'll do another little video for the key features of these graphs.